All right, so we're going to look at this function. We have f of x is equal to 3x over x squared minus x minus 2. Now this is a rational function, and I know that because it's written as a fraction. And so remember how this is different from our polynomial functions because we now have a denominator that we need to worry about. So the first thing that I think about is setting the denominator equal to 0, and that's going to help me find those vertical asymptotes. And so I look at x squared minus x minus 2 equal to 0. Since it's a quadratic, you see that power 2, I will try and factor, or you can use quadratic formula. So to factor, because I see it's just x squared, it makes me want to put x and x. Now the ending parts have to multiply to negative 2. The only things that do that are negative 2 and 1, or 2 and negative 1. But notice our middle term is negative 1. So what's going to work here is if I put a minus 2 and a plus 1, because again, when you check your factoring, you should be able to redistribute or FOIL. That's x squared. We have x times 1 is 1x. Negative 2 times x is negative 2x, and then negative 2. So remember that middle section here, that's negative 2, and the outer section here, that's what gets us our middle term, which combines to be a negative x. Okay, so we know we factor correctly because it multiplies out to be the polynomial we started with there. So now since we know it's factored, we set it equal to 0. That means that each of these factors, we have x minus 2, x plus 1, could be 0. So if x minus 2 is 0, we add 2, that tells us x equals 2. X plus 1 equal to 0, minus 1, we get x is equal to negative 1. So there we go. Those are our vertical asymptotes. Since we're talking about asymptotes, the next thing that we'll want to look at is the horizontal asymptotes. And remember, those are about really the end behavior of our graph. So what's happening when x gets really big, going to infinity, or when x gets really small, going to negative infinity? That's really the question. And so you can see, looking back at our function, that the degree is larger on the bottom than the top, which has a degree of 1. Even though we don't write that, that's what it is. And so the bottom of our fraction is going to get really, really big. So as the bottom of a fraction grows and grows and grows, that's going to actually head to 0. So our function is going to be going to 0. So that tells us my horizontal asymptote is y equals 0. Again, that's because the degree of the numerator was less than the degree of that denominator. So that denominator is growing fast. So we have our asymptotes. The next thing that I'd want to find is some intercepts. So remember, if I want to find the x-intercept, that's really saying, well, when's my function equal to 0? And a function, that's a fraction, is only equal to 0 if the numerator is. So we'll set 3x equal to 0, divide by 3, divide by 3. We get x equals 0 is our x-intercept. So 0, 0. And that's also going to be our y, and you could kind of double check. But if you plug 0 in, you're going to get 0 on the top, negative 2 on the bottom. Well, that's just 0. So again, when we let x equal 0, we get 0. So you can see that 0, 0 happening again. So this is going to be helpful, but we're also going to have to plot some additional points so we can get a better idea of what's going on. And so if I plot what we have so far, I'm going to graph our vertical asymptotes, which are at x equals 2. Let me fill in a few more values here. So we have our coordinate plane happening. And so at x equals 2, we have a vertical asymptote. I'm going to draw that. At x equals negative 1, we have another vertical asymptote. And we also have a horizontal asymptote at y equals 0. That's really the x-axis here. And we know that we touch at 0, 0. I'll plot that in blue there. So remember, you can cross a horizontal asymptote, but you're not going to cross a vertical asymptote. And so what's happening here, our polynomials that we were graphing were always some sort of like squiggly thing going on. For these rational functions, they're split up, and the vertical asymptotes are what are splitting us up. And again, that's because those are x values that we can't be, because a fraction cannot have 0 in the denominator. You can't divide by 0. So if I'm going to make a table what I'm going to want to do is choose some things to the left and right of those asymptotes. So if this first one was at -1, I'd probably want to plug in a -2. And then to the right of that, so I'll plug in -2 and see what's going on. To the right of that, I have a 0 already, so I'll probably plug in a +1. And then our other vertical asymptote is at 2, so then it makes me want to plug in like a 3. And when we plug in, you're plugging into the original function, or you could plug it into the factored function. Sometimes that's easier, doesn't matter. So if I'm looking at like f of -2, it's going to be 3 times -2 over -2 squared minus -2 minus 2. And I like to plug it in all those parentheses, especially with that negative, to make sure I don't lose it. So on the numerator, I'm going to get -6. In the denominator, order of operations, I'll square that. That's going to be a 4. -2 is going to be +4, and then I have -2. So it's going to be -6 over, kind of combining, 4 and 4 is 8, 8 minus 2, -6 over 6, which is -1. So the point that I would want to plot is an x value of -2 and an output or a y of -1. So at -2, I'm at -1, which would actually end up being right here. So I know this portion of my graph is going to be hanging out down here because I'm not going to cross the x-axis another time. Now, if you're not sure about that, you could plot another point. So you might want to plug in like -3. And again, you're plugging into that original function. So you're trying to find like, what's f of -3? Well, 3 times that -3 over -3 squared minus -3 minus 2. That's going to be -9 over, we'll have 9 plus 3 minus 2. That's -9 over 12 minus 2 is 10. So we're going to get -9/10. So I know when I plug in -3, I'm going to be really close to -1. And so it'll be right in there. And the numbers will be fractions. Those are totally fine. And you can plot those in Alex. Again, totally fine. You'll just use the plot pointing tool instead of actually just placing down a little dot or drawing the dot. So let's just try a couple more. If I plug in a 1, f of 1 is going to be 3 times 1 over 1 squared minus 1 minus 2. That's 3 over 1 minus 1 minus 2, which will be 3 over, the ones will cancel, -2. So we're going to get -3/2. So at 1, remember 1 was right there next to 0, we're going to be at -3 over 2. That's actually -1.5. So you can use decimals or fractions, whatever makes you feel better. And so we'll be about right here. Now, one thing that I might want to just figure out is if I'm going to be crossing through that point at 0, 0, or if I'm going down. So what I mean is it could look something like cubic, or it could look more like a parabola thing. So not quite sure. So then I would plug in something between 0 and -1. So I'll plug in -0.5 and see what happens. So that's f of -0.5. So we'll do 3 times -0.5 over -0.5. We'll square it, subtract it, and -2. And so you can use your calculator right here so we can see what's going on. So we have 3 times -0.5. That's going to be -1.5 in the numerator. The denominator, you square -0.5, it's going to be a positive 0.25, plus we'll add in 0.5, and then we'll minus 2. So 0.25 plus the 0.5 minus 2 gets us -1.25. So if we take -1.5 divided by -1.25, we end up with +1.2. So -0.5 gets us +1.2, which will put us about right in there on our graph. Okay, so I'm going to connect those dots there, and it looks more like a cubic kind of thing. Remember, you don't cross the vertical asymptote, you're just going to get closer and closer and closer. And so then the last thing that I want to check is, again, right on the other side, which would be a 3. So if I plug in 3, f of +3 this time will be 3 times the 1. Or, I'm sorry, not 3 times the 1. Let me undo that. The formula had 3x, so we're going to write 3 times 3 over, we'll square the 3, minus the 3, and minus 2. So what that's looking like, let me kind of zoom in here to this mess. It's going to be 9 over 9 minus 3 minus 2. That's 9 over 9 minus 3 is 6, minus 2 is 4, so we'll get 9/4, which is really 2 1/4 or 2.25 if you like that better. So again, you're plugging in a 3 and you're getting 2.25. So if I go over here, when I plug in a 3, I'm at 2.25. All right, so that's what we have. And that really means that my picture over here is going to have to do something like that. But if you want to, again, be more accurate, you could plug a 4 in and see what happens. So hope that helps. Good luck.